Alright, boys and girls, welcome to our third video lesson in Chapter 8. Another day, another dollar. 8-3, our lesson on geometric sequences and series. Okay, a geometric sequence is a sequence where we are multiplying each term by a common ratio, which we're going to call r. In other words, if our first term is a sub 1, our next term, a sub 2, is going to be a sub 1 times r. We can always find the r, the common ratio, by dividing any consecutive term, any two consecutive terms. So a sub 3 divided by a sub 2 is equal to r. A sub 2 divided by a sub 1 is equal to r, or more generally, a sub n divided by the previous term, a sub n minus 1, is also equal to our common ratio. You can see it's very similar to the arithmetic sequences. The rule for the nth term of a geometric sequence, or in other words, our rule for a geometric sequence is a sub n is equal to our first term, a sub 1, times r, our common ratio, a whole bunch of times. We're going to multiply our terms by r a whole bunch of times. We're always going to multiply by one less than the number of term that we're on. You can see now that a geometric sequence is in essence an exponential function. It's an exponential function because our n minus 1 is in the exponent. We will derive the formula of the sum of a finite geometric sequence. In other words, we call that a series, right? You know that. The sum of the sequence is the series. We will derive this in class, but S sub n, or our summation, is equal to the first term times 1 minus r to the n power, all divided by a 1 minus r. And we'll derive that formula in class. And this is kind of crazy. We can also find the sum of an infinite geometric sequence. The sum of an infinite geometric sequence. In other words, if the sequence goes on forever, it's still possible that our series has a sum. The sum of an infinite geometric series, and we'll derive this in class as well, is S sub n is equal to the first term, a sub 1, divided by 1 minus r. This only works if r is a fraction somewhere between 0 and 1. In other words, the absolute value of r, so r can also be negative, but r has to be in the range of, let me get my pen, negative 1 is less than r is less than 1. Okay? If r is a fraction or a number bigger than 1 or less than negative 1, then our series is going to be divergent. In other words, it goes to infinity. Its value is infinity. It's divergent. Okay, what are the first 5 terms of a geometric sequence if a sub 1, I didn't write that here, but a sub 1 is equal to 4 and our r is 2. So if a sub 1 is equal to 4, a sub 2 is going to equal a sub 1 times 2, which equals 8. A sub 3 is going to equal a sub 2, which is 8 times 2, which equals 16. A sub 4 is going to be 16 times 2, 32. And a sub 5, of course, times 2 again is going to equal 64. We can also find the rule for this sequence. We know that a sub n is equal to a sub 1 times r to the n minus 1 power. Well, a sub 1 is 4. Our r is 2. And we're going to raise that to the n minus 1 power. We can see now if we wanted to find a sub 5, which we knew was 64, we can plug in here. A sub 5 is equal to 4 times 2 to the 5 minus 1 power, which is 4, of course. So a sub 5 is equal to 4 times 2 to the 4th power. Let's do our order of operations. 2 to the 4th power is 16. So a sub 5 is equal to 4 times 16, which equals 64. And sure enough, it's the same answer as we get there. Okay, let's do a geometric sequence defined recursively. Again, in a recursive sequence, we always start with our first term. Our first term is 81. Our second term is going to equal our first term times 1/3, which equals, I wrote 80, I wrote 18, silly me, that should be, let me cross it out, 81. 81 times 1/3 is 27. You can see now we're multiplying by a third each time. A sub 3 is going to be 27 times 1/3, which equals 9. A sub 4 is equal to 9 times 1/3, which equals 3. And a sub 5 is going to equal 3 times 1/3, which is 1. So now we can write, if we wanted to write a regular rule for this, we know that a sub n is equal to a sub 1 times r to the n minus 1 power. Well, our a sub 1 was 81. Our r is 1/3. And we're going to raise that to the n minus 1 power. Alrighty, we're going to write a rule for the following sequence, where our first term is 3, our second term is 36, our third term is 432. Well, we're going to write a sub n is equal to a sub 1 times r to the n minus 1. We need to figure out what our a sub 1 is. We need to figure out what our r is. Well, our a sub 1, we can look at just right at the sequence, is 3. And to figure out our r, remember, we take any two consecutive terms. So if I take any two consecutive terms and divide them, I'm going to get my r. So what I'm going to do here, switch colors, is I'm going to do my second term, which is 36 divided by 3. 36 divided by 3 is 12. If I wanted to double check that, 436 divided by 36, if you pull out your calcs, 432 divided by 36, if you whip out your calcs, you're going to see that 432 divided by 36 is also 12. So we know our r is 12. So my rule is going to be a sub n is equal to a sub 1, 3 times 12 to the n minus 1 power. Alrighty, on this guy, we're going to find the sum, and those we're going to find the series. This is written in sigma notation. We can see now that we have 9 terms, starting with 1 through 9. It's a geometric series. Our a sub 1 is actually 1. There's a 1 right here. You can't see it there, but our a sub 1 is 1. Our r is negative 2, because I'm raising that to the, or in this case it's I, but so what? I and n are the same thing. I minus 1 power. So if we want to use our formula, we're going to write, here S sub n is equal to our formula, which is a sub 1 times 1 minus r to the n all over 1 minus r. So our a sub 1 we said was 1, so S sub n is equal to 1 times 1 minus negative 2 raised to the 9th power all over 1 minus negative 2, because our r was negative 2. Pull out your calcs. Negative 2 to the 9th power is, don't tell me I'm doing this one in my head, is negative 512. So S sub n is equal to 1 times 1 minus negative 512 all over 1 minus negative 2. 1 minus 512 is 513. All over 1 minus 2 is 3. So our S sub n, let me pull out my calc real quick, 513 divided by 3. Our series is equal to 171. Okay, in this guy right here, we're going to find the sum of an infinite series where we're actually starting at n equals 0, but that's okay. Just plug in, our first term is when n is equal to 0. So our first term, if you want to think about it, is 2 times 2/3 raised to the 0 power, which of course is 1. So 2 times 1 is 2. That's our first term. Our second term is going to be 2 times 2/3 raised to the first power, which is going to be 4/3. We can see we're multiplying by 2/3 each time, so our next term is going to be 8/9. Our next term is going to be 8/9 times 2/3 is 16/27. We're going to do this forever. We're going to add all those fractions up to infinity. Well, let's see if they come to an actual value, and they do, because I know that, because my r, 2/3, is a fraction in between -1 and 1. So we're going to use our formula. S sub n of an infinite sequence is going to be a sub 1 divided by 1 minus r. In this case, our a sub 1 is 2. I'm going to write that in blue right here. 2 divided by 1 minus r. Our r is 2/3. So 2 divided by 1 minus 2/3 is 1/3. 2 divided by 1/3, when you're dividing fractions, don't ask why. Flip the bottom one over and multiply. 2 divided by 1/3 is the same thing as 2 times 3 over 1. So our sum, believe it or not, if I add up all those fractions forever and ever, I get a value of 6. Our series converges at 6. Hey, that's it, folks. Have a great day, and we shall talk to you soon.